Stan Gibilisco here, proprietor and operator of amateur radio station W1GV, Whiskey 1 Good Vibrations, to briefly describe an alternative to the Kite Zep that I described for the Stargazer Ranch a while back. This is a 256-foot, that is a half wavelength, end-fed wire at 1.825 megahertz. A wire like this will present an extremely high, purely resistive impedance at the feed point. That extremely high, purely resistive impedance has some advantages, but also some problems. And the biggest problem is that an ordinary antenna tuner can't handle it. But that T box right there is a homebrew antenna tuner, greatly enlarged in size, placed right at the feed point and preset and pre-adjusted and then left alone so that I can operate on and around the frequency of my choice here. That's the truck, big number 8, lifted to contend with the weather here in the black holes of South Dakota, United States of advertising. These are 4 radials laid down in the mud, quarter wavelength, 128 feet, to ensure somewhat of a ground system. But nevertheless, even with a marginal ground system, a 4,000 ohm purely resistive impedance like that will offer good antenna efficiency. The tuner will tune this to a 1-to-1 standing wave ratio for the coax to the radio. So that is the gist of it. I park the truck a little ways away from the Stargazer bunkhouse and tune that tuner and go to it. Well, you might wonder, what kind of a tuner is this? Well, it comprises a 26 microhenry roller inductor, available from Palstar, the company that makes the transmatches. There's how the coax is connected. This is 26 microhenries from end to end. The tap there, the coax center conductor goes to the tap. The shield goes to the ground here. A transmitting grade variable capacitor is connected across that coil, and it has to be a transmitting grade capacitor because the high voltage that will be caused by this high impedance would arc over even on a low power level on a receiving variable. So I found a variable capacitor also available from Palstar that has a maximum capacitance somewhere in the order of 460 picofarads. Now this roller inductor is $159, and that thing's $149, so this bugger ain't cheap, but they're good and rugged components. I build it in a nice shielded weather sealed container so that it would be able to withstand the conditions out there. Then I would adjust this capacitor and this tap for a 1-to-1 standing wave ratio on that coax. What we really get here is a tank circuit right there, and once we get that thing resonated at the frequency of choice, once again, and I have just chosen here for argument's sake 1.825 megahertz, resonant at that frequency, I calculated the amount of capacitance that it would need, and it turns out to be 293 picofarads, easily within the range of this capacitor. So we get this thing resonant, and then we move that tap up and down there, and all of the impedances that you will see along that coax, or that coil as you move the tap, will be purely resistive. 0 down there, and the maximum of about 4,000 ohms up here, and somewhere in there you're going to find a 50 ohm sweet spot. And once you've found that sweet spot, you've got a 1-to-1 standing wave ratio. You can pretty much leave that thing alone, and it should be able to withstand up to 50 or 100 watts pretty easily. I wouldn't run a kilowatt into one of these under any circumstances, but this kind of antenna tuner can deal with a half wavelength antenna like this, whereas most tuners can't. And so that's what I would plan to do if I can afford to go out there at all this winter, which is a whole nother question that W1GV must pose to himself as he tells you 73 and bids you so long for now.